Okay, 2.5 is going to be about solving quadratics. So we've been talking about linear equations. Now we're going to step it up to quadratic equations. This is general form of a quadratic equation. The main thing here is we have some x squared term. So that's going to add another layer of difficulty in solving these equations. So let's first start with the simplest type of solving, and that's going to be solving by factoring. Whoops. Come on. So to solve by factoring, we must use the zero product property. The zero product property says if A times B equals 0, then A equals 0 or B equals 0. Okay, just using that fact that anytime you multiply something by 0, then one of the two factors has to equal 0. So if we have something like this, this is a quadratic, it's already in factored form. I can say x equals 0 or x plus 3 equals 0. Both factors set equal to 0, and then solve each of those individually, and I get my two solutions. Here's another one, already in factored form. This one's two binomials. X minus 2 equals 0, and x plus 5 equal to 0. Taking the two factors and setting equal to 0 and solving each of them, I get x equal to 2 and x equal to negative 5. That's my two solutions. If we have something like this, it's not in factored form, but we can factor it by factoring our greatest common factor of x, and then we can take the factors and set them equal to 0. And we get x equal to 0 and x equal to negative 4. Another example. Okay, this factors into x minus 6, x plus 4. Take each of those factors, set it equal to 0, and we get x is equal to positive 6 and x is equal to negative 4. Okay, difference of squares. This factors into x plus 3, x minus 3. So we got x plus 3 equals 0 and x minus 3 equals 0, which gives us negative 3 and positive 3. Okay, even one that's got a lead coefficient other than 1. Now, these are a little bit harder to factor. You can go on Google and look up the process for factoring these guys, but I use something called the bottoms up method, but there's a lot of different methods. So say I have 6x squared plus 7x minus 3 equal to 0. And we'll first go over here and factor it. We'll factor just the left-hand side. Again, this is my process. You can look it up on Google, called the bottoms up method. I'm going to just go over it real quick. You're going to take this over and carry it over and multiply it in. Gives you that. Factor that guy. X plus 9, x minus 2. Then bring this back down. 9 over 6, 2 over 6. Simplify those fractions. 3 over 2, 1 over 3. And then kick both of those guys out front doing this. And there's the factored form. So bringing my factors back over here to solve the equation, I have 2x plus 3 times 3x minus 1, set equal to 0. Take each of the factors, set them equal to 0, and solve. 2x equals negative 3, x equals negative 3 halves, 3x equals 1, x equals positive 1/3. Okay? Now, let's do something, solve some quadratics using the square root property. Now, the square root property basically just says if we can take a square root to solve it, then we can do that. For example, say I have x squared equals 25. Okay? I can take the square root of that to undo the x squared. We need to remember that anytime we take a square root of something, we have the plus and the minus. So there's my two answers. Okay? Another example, x squared equals negative 17. Square root. Okay? We have a plus or minus. It's a negative, so we bring an I out. And that doesn't simplify. So it's just plus or minus I square root of 17. Okay? If I have something like this, square root both sides. We can add the 2 over, and then x, or 2 plus 4 is 6, and 2 minus 4 is negative 2. Similarly, if I have, say, x minus 4 squared minus 15 equal to 0, I can solve this by adding 15 to both sides. Whoops. Square root both sides. And then add 4 to both sides. So I have two answers because I have the plus or minus. I'm just going to leave it like that though. Okay? Now, to go from this to our next way of solving them from one like this is we have to do something called completing the square. Now, I'm not going to take the time to show all that, but basically there's a process called completing the square. You use the process of completing the square to derive the quadratic formula, and most people are familiar with the quadratic formula. So I'll post another probably YouTube video, probably not anything that I have done, just somebody else that shows you the process of deriving the quadratic formula. I can do it, but it takes a lot of time, and I am not going to require you to memorize that. So basically what that says is if we go in general form, and this can be used to solve any type of quadratic, general form, if we have that, the solution is going to be taking the coefficients and plugging it into this little formula. Okay, that's the quadratic formula. And I'm sure that most of you have heard of that in high school at some point. Okay, so when we do the quadratic formula, it's fairly simple, but it has its own issues with the simplification. All you got to do is just be careful when you're simplifying. So if we're going to solve something like this, A is equal to 1, B is equal to 5, and C is equal to 1. If we plug it into this formula right here, make sure and always put everything that you're plugging in parentheses. For example, negative B plus or minus the square root of B squared minus 4 times A times C. Oops, let me take that out. All over 2 times A, which is 1. So that's going to give me negative 5 plus or minus the square root of 25 minus 4 all over 2, which is negative 5 plus or minus the square root of 21 over 2. Okay? Another example, x squared plus x plus 2 equal to 0. That's A equal to 1, B equal to 1, C equal to 2. Negative B plus or minus the square root of B squared minus 4AC all over 2A. So negative 1 plus or minus the square root of 1 minus 8 over 2, which is negative 1 plus or minus the square root of negative 7 over 2. And we need to not have square root of negative numbers. So we're going to say I square root of 7 all over 2. Okay, now let's look at this discriminant. The discriminant is the part under the radical of the quadratic formula. Discriminant is pretty important because if it's negative, or if it's positive, we know that we're going to be having real solutions. If we know that it's negative, we're going to have complex solutions, and we know if it's equal to 0, we're going to get rid of that plus or minus, so we have one solution. So this is going to give us 2 real solutions. Run out of room. This is going to be 2 complex. And then, of course, if it's equal to 0, we're going to get rid of that plus or minus, so we have 1 real. So let's say I have 3x squared plus 2x minus 6 equals 0. What kind of solution are we going to have here? So if we just look at the discriminant, it's going to be 2 squared minus 4 times 3 times negative 6. So that's going to be 4 plus 72, which is 76, which is greater than 0, so we have 2 real solutions. That's all you have to do. It's just basically saving you some time by finding what kind of solutions you're going to have before you even approach it. Because sometimes in mathematics, it's more important to know what kind of answer we're going to have before we even approach it. Because if we know that the problem we're working on is going to give us non-real solutions, then there's no real-world application. So if you're working in an industry, there's no real-world solution, we don't even proceed with the problem. So sometimes in mathematics, it's not necessarily about finding the problem, it's about finding if there even is a solution to the problem. And this is an example of something we can use to determine if something's going to have a solution or not. So we're going to stop.